Introductory programming environment that combines sort of multimedia and allows kids to create projects that that sort of address their interests and help them express themselves. And so actually the genesis of Scratch was we were doing a lot of work with after-school centers, in particular this after-school center called the Computer Clubhouse. And we saw kids doing a lot of stuff with media tools such as Photoshop, Bryce 3D, tools like Game Maker for putting together games, tools that would like Acid Pro and GarageBand that would let them create music and make their own kind of CDs and stuff. And we saw them doing all this stuff with media, but what we didn't see was a lot of programming. We did see a little bit of programming, but not a lot. And we thought that was a missed opportunity. So we set about, we got a National Science Foundation grant to create Scratch. And we set about making something that would incorporate a lot of different media elements, but allow you to program them. So to cut to the sort of the actual Scratch. So over here we have a stage area, and on it initially is this one cat thing, which we call a sprite. You can create multiple sprites, and they can all interact and stuff. But initially you get one. And over here on the far left is this command palette with color-coded commands, and I'll just start with this first one that says move 10 steps. And if I move this over to this scripting area here and double-click it, you can see right away what it does. It makes it move forward a little. You don't have to really know what exactly 10 steps means. There's multiple different command categories, and here's one called sound. And in the sound category is this block that says play drum 48 for 0.2 seconds. So that's in this case you kind of hear the result of that. The simplest kind of programming you can do is to sequence commands. So here it says move and then play this drum sound. So let me try that. So it moves and it plays a drum sound. I can duplicate those two commands and then make a little bit of a change. So I'm going to change. I want it to go backwards. I want it to go forwards and then backwards. So to make it go backwards, I can click in this place where it says move 10 steps, and I could put a minus sign in front of that. So the way you go backwards is you go forward minus. So this introduces this idea of negative numbers. So now he goes backwards and he's playing that same drum sound. But I'll pick from the menu, I'll pick a different sound. So here's a cymbal sound. Now I could put all of those together, and you see he does like a little dance step. But I have to keep double-clicking to make him dance, and it'd be nicer if he just did it on his own. So let me go to this control category and see what we have. Here's a little block that says forever. And this is what we call a loop. So you can put those 4 commands into that loop, and you see it sort of opens up to fit them.
What I love about this is you're naturally teaching them in their mind programming languages.
Yeah, and they don't even know
I'm a coder from old time.
Right, and you actually see there's sort of indented statements inside of a loop. Yeah.
This is great.
So so if I double click this, we see it starts looping, but actually while it's changing, and this is something that you can't do in many programming languages, I can change things about it. So I could change this 0.2 to something like 0.4. So now it's a little bit uneven, and I can change this other one to 0.4. And now I've slowed it down. So we call this feature sort of tinkerability. You can tinker with the program even while it's running. And that invites a kind of exploration and discovery it's a little, you can do that in other programming languages, but it takes more patience, because usually you have to go into an editor, change the code, compile it, run it, see what happens, and then repeat that whole cycle over and over and over again. This is a lot more immediate and direct.
And it also has color and other attractions for the kids. I apologize, I might have missed this. What age group is this geared towards?
It was originally aimed at, I guess, 10 to 18. It turns out I think it works better. It works down to lower ages, like 7 or 8. Yeah. Somehow older teenagers get less engaged in it, but then young adults, like in their 20s, seem to get interested in it again. So what we see is a sort of a big, in the age graph, we see sort of a spike right around 12, going from like 8 to 14, and then we see this long tail that goes out to like 40 or 50, where what we've actually seen on the Scratch website is that professional programmers play with Scratch in their spare time and post projects, sometimes very sophisticated ones. The most amazing project that got posted was somebody who was a computer graphics whiz, 3D computer graphics, posted a project, a Scratch project, where they actually did, like, rendered a 3D scene, you know, with like the typical 3D scene with a ball and a cube and a checkerboard pattern, and they actually did ray tracing and, you know, drew all of this with reflections and shadows and everything. It took, you know, half an hour to draw it all, to draw this whole thing, and we went, wow, that's like so far beyond what we ever expected to see anybody do in Scratch.
But did it with the Scratch language.
They did it in the Scratch language, and what was interesting about that is they posted it on, we have a website, which I'll show you in a second. They posted it on the website, and then kids were saying, well, that's amazing, how did you do that? And then this guy, the poor guy who did it, had to sort of explain, well, let's see, I need to tell you about trigonometry and matrices, but there were some kids who actually were interested enough to kind of continue that conversation through the comments on the project, through several steps. And we actually had somebody write to us and say, you know, I'm using Scratch to teach myself about trigonometry, which was like amazing. I mean, you know.
I think the trail walk you described is based on increasing emphasis on product. That as kids get older, school's all about what you turn into.
Oh, the tail off after, like, you know.
Then once you sort of grow up, you realize that was all nonsense.
The other thing I think the other thing that happens, at least with American kids, is they start to realize that there's a big difference between what they can do as an individual sort of amateur playing around with something like Scratch and what, you know, a team of you know, 40 people with a couple $1,000,000 can do, you know, turning out an Xbox game. And I think they start comparing themselves to those professional efforts.
Well, the product is they're comparing products.
They're comparing their what they can do with products, and they get discouraged.
Right.
Some of them, at least. And
the whole process idea is the same, whether you're doing it at a lower level or a higher level.
Yeah.
So it's undervalued.
But it's,
and we've talked to some, you know, educators who are working with kids, actually doing, you know, sort of little gaming workshops and stuff, where they actually model the sort of professional game development thing, and they've got like an artistic person, and they've got a coder, and they've got somebody responsible for level design.
You can change images, all the sprites. You got multiple sprites, so you got things interacting with each other.
Yeah, let me show you some of the kinds of things that that people make. So.
And there's a share button built right into the software, which puts it on the web and a social network where people can critique and comment and rate, and they can grab your code and use it, take it apart, use it in their project.
Well, I mean, this is
really strong.
Yeah. Here's
Your laptop there. What OS do you have? Do you have Linux or Windows?
This is actually Mac OS, but the Scratch, we have Scratch mostly working on the XO, and you can actually go to the activities page on the OLPC wiki and download the current version. Some of the fonts are too small. That's one of the biggest issues that we're facing, kind of making it work well on the XO, is to get everything big enough to be legible, because the pixels are so small on that screen. But we're definitely working on that. And then the other thing that isn't quite working yet is the sort of note and drum commands. We don't have access to a sort of a MIDI synthesizer, which is what we were using on Windows to get those sounds. But we're working with Barry Verco, who's like big in the XO world, to make C-Sound play the note and drum type sounds. So this is, and I can actually kind of go full screen on this. This is a Tetris game, and you can, I forget how you rotate stuff. I already hit the wrong controls. Left and right arrows, up arrow is rotate. So rotate, 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 rotate. And that, I guess, drops it to the bottom, which was. So, this is, oops, yeah, not very. This is pretty amazing. This is, again, like somewhat beyond what I would have expected most kids to do.
Someone coded that. That's awesome.
Yeah, yeah. And if you look at some of the scripting for it, it gets pretty involved. I mean, it's you know, lots of scripts in these different pieces.
Still 2 pages of code.
Yeah.
Well, it's 2 pages of code replicated in all those different pieces. But yeah, it is only 2 pages of code. That is a good thing. Yeah. So the website is PHP with a Java player for this thing.
Yeah.
So this is the website, and so once you've created a project, you can upload it by just clicking this share button to the website. And on the website, this is the home page. There's a list of new projects that we've featured. Let me just go to one of these random featured projects.
One of the projects has probably just a guy walking forward.
Yeah, right. I mean, that's the thing, is that people upload their beginning projects, and that's fine. So they're not all, you know, they're not all like the Tetris game. This one looks this was a featured project, so it looks fairly sophisticated. It looks like you're supposed to guess. Let me see here. 3 cups, 1 ball.
My 10-year-old would love this.
Click the green.
So okay, so I clicked it and the ball went in that one, and I guess if I choose the speed with the 1, 2, 3 buttons, click a cup, click the.
To shuffle the cups.
Oh right. Okay, so click the red rectangle is the.
Choose which one you think it's under.
So this is the thing that shuffles the cups. Yep. Okay, so is that where the ball was? No.
So now you click on the number. Oh.
Yes. Okay, so then reset would put it back. So I'll put it in the middle. Actually, I guess I could click this to speed it up.
Wow.
And I have no idea, but let's say it's there. Nope, not there. There it is.
That's great. That's incredible.
Right, so I invite you to go to the website, which is scratch.mit.edu.
Okay, scratch.edu.
And download it and try it out, or get it onto your EXO by going to the OLPC wiki.